Hey everybody, this is Larry. This is hello. This is me trying to load the problem. And it is loading. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about today's problem. And we have day 23, presumably part 2 of whatever we were doing yesterday. I'm really tired today because I ran 3 miles, not that much, 5K, but I tried to do it very fast, so it was kind of hard. Yeah. So I think this is probably what happened yesterday, so let's take a look. Okay, yeah, sorry, it was taking a while to load. Everything, do I need a new computer? Everything always feels so slow. But yeah, with 3510, minimum pair removal to sort away 2. Yeah, so that's today's problem. Let me double check. Okay, adjacent pairs, replace. I mean, anytime you want to get the minimum thing repeatedly, the first thing that should come to mind is maybe heap, sorted list, or something like that, or segment tree maybe, but that may be too crazy. Yeah, so, but for me, the first thing that comes to mind is heap, right? Yeah. And that's really it. And then it's just about keeping track of things, right? So that we don't keep on remove or so we don't because basically the key idea is that you have to be able to remove stuff as quickly as possible, and also get so 2 things you want to do, right? You want to remove and replace as quickly as possible, and then you want to use a heap, right? So yeah, I mean, I think you can do so a heap for getting minimum. Okay, I'm not going to go over that until we implement it a little bit more. But the replacement thing, right? There's actually 2 ways that I'm thinking of doing it now, just off my head. Maybe I should have thought about this yesterday, but I don't know. These things are always a little bit weird, Like I feel like because in terms of these videos, because I'm trying to. I don't know that I really thought about it that much because this idea just came to me, but it still feels a little bit awkward of like, oh, look at, watch me solve it live, this problem that we talked about kind of yesterday, and we know that it's coming. So it makes it a really weird daily problem. But I don't know, I'm trying my best. But actually, honestly, I actually didn't think about it that much because, I don't know, I knew I was going to think about it today on cameras. I was like, whatever, right? But there are 2 ways, right? One is one way that I was thinking about is to use a sorted list in some way, because you can just like remove arbitrary things from a sorted list in log n time, and then you could insert things also in log n time, and you could check its neighbor, right? Does it log n? Yeah. Then check its neighbor in log n times, and then update the heap, right? So that's one way. The other way that I would be thinking about is using a linked list, right? Because, well, it's just a perfect natural fit algorithmically, right? Data structure wise. Implementation may be a little tricky, but data structure wise, that should be a perfect fit because you just replace the number with a sum. You have a linked list, maybe with a doubly linked list, probably a doubly linked list. Then you just kind of merge adjacent elements, right? So that's basically the idea of what I think I'm going to do is I convert it to a double linked list. We put everything inside a heap. And so there are 2 ways to do it with the heap, right? One is just a heap, and then the other is with if you do it with a heap, you have to do it with a lazy heap, right? Because you cannot remove stuff from the middle. And the reason is because if you have now let's say you have a doubly linked list, you merge 2 items, well, that means that you have to add stuff to it, which is easy for a heap, but you also have to remove previous pairs, right? Meaning that if you have, let me ask you all this stuff. If you have A connected to B, connected to C, connected to D, well, if you kind of merge B and C, right? So now you have B plus C, right? Oops. So you have this, you go from here. So you update the heap, you add A and a new neighbor of D. So this is a new pair that you add to the heap. This is a new pair that you add to the heap. But you have to remove this pair, right? A and B, because it's no longer part of the new linked list, right? So that's it. That's kind of the idea that I'm thinking of. So start, we'll start with a linked list. So we'll just start with a node, right? Self.value is equal to value. Maybe that should have been in the thing, right? And you could set it up however you like, but that's just the way that I'm doing it, right? Yeah, and then now you can start by, I don't know, we can have like a head node, which is a sentinel node of -1. I don't know how I feel about that. Maybe we'll change it up. But then now for x in nums, we do current is equal to head, right? So then current.next is equal to a new node. Oh, I wrote left and right instead of next and previous. Maybe this is a little cleaner actually, because I'm just, I mean, I don't really memorize these things, so it just whatever feels natural. Though often when you do things enough times, yeah. Actually, maybe node is equal to this, right? So node.previous is equal to current, and we're done, right? And then current is equal to node as we move, right? Or current equal to current.next, right? And then at the end, you can maybe even say tail is equal to whatever, but it doesn't really matter. And then now we have to set up the heap. So I am going to do it the sorted list way, just because I use sorted list like a heap, right? So maybe we'll just call it H for heap, but use a sorted list. I don't remember after. Someone told me that you don't need this anymore. Is that true? Let's see. Does it tell me that I have to import? Oh, I don't have to import it anymore in Leetcode. Oh, that's kind of nice. Maybe, hopefully, anyway. But yeah, but then now, yeah. And then we can say current is equal to head, while current.next is not none. Or maybe this is .next actually. So while current is not none, then yeah, maybe this is fine. While current.next is not none, then we take the current.value plus current.next.value, right? So that's the heap item, right? So we do H. I don't know if this quite works actually with a heap, or with sorted list rather. Because what I want to write is something like add, you know, this is the sort element, and then maybe you want the current as the pointer, right? Yeah. But as a tiebreaker, it may try to sort by this, which maybe is not quite, maybe you can sort by a node. So I think this actually technically doesn't work, but we'll just write it this way anyway for now as a placeholder. Let me run it real quick. Let's see. Because if this tiebreaker, it may try to sort by the item and then give you an. Maybe it doesn't. Oh, it's there you go. See, that's what I was thinking of, right? Because it cannot sort, so you can't really do it. How do I want to? Now I need a placeholder then. Oh, I guess actually the leftmost one is the tiebreaker, so that's what we want anyway. And so we need a unique thing. So maybe like a self.index or something, right? And this is the original index, so it will always be unique, right? Because when you merge, you just kind of keep one of the index. It doesn't matter which one as long as you're consistent about things, because then you just don't get dupes, right? So then now we can store current.index, and then it should never tie break enough to it to go to here. So now it should be good. Well, we have to whatever. Right? Okay. And then now we can handle it one item at a time from the heap, right? So while length of heap is actually, I messed up a little bit. I forgot this like sortedness thing. I forgot about this non-decreasing thing. Can I do it this way with non-decreasing? I mean, the answer is yes, but I'm trying to think whether there's an easy way to do it. The not easy way that I'm thinking of my mind is just counting the number of inversions, right? Which kind of, that's the first thing that comes to mind. Because to be honest, some of it is just going to be experience. I'm not trying to like, you know, be like, oh, it's magic. It's just that I've done a lot of similar problems. And the idea behind this is just find equivalent things, right? And non-decreasing means that the number of inversion is 0, right? Meaning that there's no inversion. And if you don't know what inversion means, let me go over it very briefly. So inversion should be 0, right? So here maybe we do inversions is greater than 0, then I have to do stuff. But basically, an inversion is such that if it's basically something that's out of order. If a sub I is greater than a sub j for I is before j, then yeah, that's basically one inversion, right? So then just sum it all up, and then that's the number of inversions. So I have to figure it out, and I'm going to do even more work to get the initial inversion, and then try to figure out how to subtract all of them. And with that, I think technically you want that's annoying, isn't it? I mean, you could use another sorted list. You could use a segment tree, a sparse segment tree. You could use a sparse. Maybe you can use. I mean, you can, but it's. I forgot that the key values are not static, so you can't really do a rekeying easily. So yeah, maybe a sorted list is the easiest, right? So maybe previous is equal to sorted list. So then now, wow, this one is really annoying, isn't it? I'm trying to think a little bit better, like. I'm trying to think whether there's a easier way to do this, or I'm just being crazy. Which, well, actually, I guess I could be both, but I'm still just trying to figure out if I could do this in an easier way. I don't know. I mean, I think maybe you can also just, instead of inversions, which is what I jumped at immediately, you probably can just maybe check the number of adjacent, sortedness. But maybe I don't know. I like inversion better, just because it just feels more. For me, it just feels more foolproof. But maybe I'm wrong here, or maybe I'm doing crazy things, right? So then here we want to say, inversions is equal to 0. So then now here we want to say after we insert the thing, we want to pre-process X, right? Oh, but that's fine for this. But then how do you keep it updated? Huh. Wait, I might have to rethink about this. I could calculate the initial inversion, but then what I'm thinking or stuck with a little bit, and so now it should be clear that I have not thought this at all. But if I have this inversion, right? How do I count the number of reversions to subtract from, right? Because doing it progressively as a sweep line is very easy, right? Because then it's just actually I don't know. I think this is actually done, right? Bisect left for the number of inversions. So like something like this, and that's actually it for the inversions. But we have to be able to subtract them from the prefix. So then you have to count the number of numbers that are smaller, but to the left. And I don't think that's the way to do this. Let me try to think the other way, right? Maybe not full inversions, but like I don't know. I forget what it's called. Like invertedness, maybe just invert is equal to 0, and then here you could say if. Maybe I'll do it here actually because it's more natural to look at it. So if current dot value is greater than current dot value or dot next dot value, then inverted increment by 1. So this is just for neighbors, right? And then maybe that's enough, right? So then now we have 2 operations, right? We just have to, or 3 operations. We remove 2 numbers, and then we move 2 numbers and we add 1 number, right? So we could break it down to 3 operations, and each of them will maintain this invertedness, right? I don't know if that's the right word, by the way, but yeah. Let me get some water real quick. Oh, did I not have water? Oh no, there it is. So I need to put more water in the mini freezer that I have. Okay. I think that sounds right. Okay, yeah, maybe that sounds right. So then now we want to get the heap. Okay, so we don't have this anymore. So we get the heap, the smallest thing from heap, right? So yeah, so maybe assert length of h is greater than 0, and then h of 0, it's going to be what do we say was? Okay, so it's just the value, which we don't care about really. Well, I guess we do. I mean, we could recalculate it, but okay, so the value, the index, and then the node, right? Okay. So then now, we move node. And index we don't really care about, except for we just use it for sorting and heap to verify who's more leftmost, right? So okay, so we move node dot left, or node dot right, or node dot next, add a new node, right? Okay, so those are the 3 things that we have to do. We could actually just have a function, right? We move node. We should also remove this actually from the heap. So this is easy, right? So far, and then def remove node, right? And this is a doubly linked list. So when we have no, so previous is equal to node.previous. Is that write out previous? Or, oh, I did write out previous. So sometimes I write out previous, sometimes I just write prev, so it's very confusing. Next is equal to node.next. We have to assert that this is actually, no, I guess it doesn't have to. Node.next.next might not have to, right? Okay, so then now we remove. Okay, so then now previous.next is equal to next, and next.previous is equal to previous, and we're good, right? That's all we have to do with the removal. But removal, we also change the invertedness, right? The inverted count. So so non-local inverted, right? Okay, so then now, how do I, is that right? I just want to make sure that, okay, so if node dot value, so if node next, or if next is not none, and node dot next dot value, I'm writing it weird. If node dot value is greater than this, right, before we remove it, then invertedness we subtract 1 because we removed it. And then same for previous, right? So if previous is not none, and the previous dot value is greater than no dot value, then inverted -1, right? But then now we have to add it back in, right? Because if then now the new state of if previous is not none and next is not none, then oh, actually I have to check some of these, right? Why don't I do it? If it is not none, then we do this. if next is not none, then we do this. That's why I thought that looked a little weird. None or one. Okay, so if previous is not none, then oh yeah, I forgot the if and previous dot value is greater than the new next value, then inverted increment by 1, right? So that's it for remove. I think that's all the states. Could be wrong. And then now we have an add node, right? How do I do it? Add node. Because we want to say remove node.next, right? But we have to add a node somewhere. Maybe we could add first. I don't know. But so previous is equal to node.previous, and this should always exist just because we have a sentinel head node. But hopefully the -1 doesn't mess anything up. It shouldn't affect stuff like this, but we'll see. I mean, I don't know, at this point this code is a mess anyway. I'm a mess today. Long story, but yeah, today's a messy day. But yeah, so this should never be none. So then now we remove, and this is previous, not just we remove. Then now we add a node at the previous, right? Maybe. So then now previous dot next is equal to node dot. Oh, what the? I guess we actually insert by the node by v, right? I guess it's just an, and then we keep the index from before. So yeah, okay. All right. So then here is equal to a new node of yeah, re-index. Let's call this node. So then now previous dot next is equal to node. I mean, this is kind of right, but it's also not enough, right? Previous is equal to node, right? But then now I'm losing the next, right? So we have to do next is equal to node dot next. No, I mean, okay, so if all goes well, previous, and that's, I mean, okay, so we remove this and we remove this, then previous should have looked at node.next already as part of this code. Yeah. Well, no, yeah. If it's correct, it might not be correct, but that's another story. But then previous dot next should have something. So yeah, okay. That assumes that yeah, this assumes that all the other invariants are true. So then now if next is not none, then node.next is equal to next, and next.previous is equal to node. And then now we have to update the heap, which I guess is kind of weird because we moved the heap here. Maybe I should just update the heap here instead to be consistent. But then now no, I mean, this is very awkward, the coding. Because we add this value is actually yeah, I don't know, it's very inconsistent. But basically we don't add the heap for now, we add the heap for, you know, for example, you add the value actually should be node. Okay, so only if next is not none, then we add node.value, so which is v, but that's fine, plus node.next dot value, right? Index, we just keep the same index of the node, so node.index, maybe that's just cleaner. And then node, right? So that's on a heap, but then we also have to do it with the previous node. I think technically when we remove stuff, we have to update the heap state so that the add state is more consistent. But we're not doing that because I don't know. Maybe it should even it out. Let's see, right? So you remove. I mean, I think that is more cleaner as an API and less error prone in the beginning. But let me think through it a little bit. Okay, so you remove a node. Then now you should update the merge node. And then when you add, you remove the. Okay, I guess it does cancel out, but it's a little bit awkward. So we'll see if that kind of comes back to bite us. Well, in previous would never be none, but as we said, because we have to head sentinel node, but it could be, but we should not count it as adding the heap if it's -1, right? So we have if previous dot value is not -1, then we add previous previous dot value plus node dot value. We have previous dot index and then the previous node. All right, is this going to be good? Honestly, no idea, right? But you know, let's give it a spin at least for this examples. Okay, well that worked pretty well actually, but I'm still not confident. But I am gonna YOLO submit just because I don't know. It's late. Wow, that's not even close. Oh, there's negative numbers. I mean, okay. If they're negative numbers, then it's a very obvious miss because I didn't, Yeah, I mean, I guess I just didn't look at it. I don't know why I didn't look at it. But here, I mean, you know, it's never going to be correct just because it messes it up easily. Especially when there's -1 specifically, but, you know. All right, let's try again. Actually, I don't know if I... okay, let's try again with this. I don't know if I added it. Okay. I mean, that's definitely a thing I needed to fix anyway. But that is odd. All right, let's take a look at the heap. Right. All right, that's pretty awkward. But okay, -1 is the smallest. Is that true? I guess so. And index 9? That's probably not right. No. This -1, that actually should be right. Okay. Yeah, I mean, it is easy to debug at least because then now we can just print the whole list. Where is it head? And then we just have to recursively do this, right? Or is it string? I mean, I could do it as string, but I thought there was another thing. I'm finding out what it's called for the print statement. Maybe it's fine. We just go... yeah, maybe just like... self dot value. Current is equal to self, while current is not none. All dot append current dot value, right? And then maybe a string version of this, and then we just return to something like this, right? And that's an infinite loops. Oh, it does infinite loop because I forgot to write current is equal to current dot next. I thought it was going to infinitely loop elsewhere. Okay, so we have this. Oh, negative numbers are confusing. So okay, so maybe we should. I was hoping this would be a thing, but okay, space is fine. I don't know why I made it too complicated. Okay, so we start with this, and this is the initial list. Okay. Okay, maybe I could get rid of the heap for a second, because the heap output is not so friendly. So okay, so you have this merge. What's next? Oh, there's this. Oh, so after for operation, it does this, but it thinks. So the invertedness is not correct. Oh, I forgot to do invertedness, didn't I? I forgot to do it on the add. Silly boy, Larry. I mean, yeah, okay. I don't know. Today's just been such a rough day. But it is what it is. Okay. Right. So I just forgot to maintain state for the invertedness. So we added a node. So then now this is. Yeah, this tracks the thing. So we have to do it for every add, right? So that means that we add a node. So then that means that from previous, we added from between previous and next. So then here, if next is not none and previous dot value inverted to -1 because we're removing it, right? But we have to add it in. That's the bigger part. And then now, if previous then if previous dot value is greater than no dot value, yeah, okay, then inverted right? And then now, yeah, if no dot value is greater than next dot value, inverted right? Pretty straightforward. I just forgot, I guess. Okay, still wrong. But the heap seems okay. Maybe. I don't know if the heap is okay, actually. Because I don't know where the 3 went. Okay, let's see. Index node. Oh, because it's printing node, that's why. Let's just do v and index. Okay, -1 for the sum. 0, index 4, maybe that's right. Yeah, these things. 0, 8, these things. 1, 1. I mean, it's this one, right? 1, 3, so 3, 0, but then we don't insert it correctly. I mean, there's the 1, 4, so the heap is getting inserted correctly, but what is it missing? It inserts a 1. Do I put in the wrong number? Because the 4 is right. Do I insert this wrong? No, because that's the node, right? This is the V. This is V is the new node. Huh. So V is the new node. And even say that it is going to be 1 and 3. Oh no, 1 is the value. Index is 3, so actually that's already wrong. Because it's 3 and 0. Okay, so I do have to look at the heap then, maybe. Okay, so okay, index is 3, but this is 1. Huh. Maybe I do have to print out heap. Okay. Because it does have a 1, 3. Node object is a little bit. I forget how. It's oh, rep. That's what it is, right? Maybe. I forget what it is. Maybe not. Let me Google. Hang on. Python object overload string. I forget what it's called. Oh yeah, no, I was close. It's web bar. It's been a while. My computer is really slow. I cannot even click through. What is my computer loading? Kill some stuff. Sorry, friends. Technology. Who knows how this works? Okay, let's take a look. Did I click on? Oh yeah, no. This is okay. So this is what I want. This is the head of the node, kind of. So that's kind of fine. But okay, let's go to 1.3. 1.3. It looks at 3.0. So this is kind of wrong. Oh wait, no, this is right. But no, I mean this is. Did the node change? No, we create a new node every time. So it goes back here, that's wrong. This is wrong because the value should be 3. That's why this is wrong. Okay, so where's 1.3? There's no 1.3. So there is some like weird typo here. Okay, so there's this thing, right? Actually, I do add heap items, so maybe there's something wrong here. Or maybe I don't remove enough things. Maybe remove. Yo, I see. Yeah, I mean, I just didn't remove enough things, right? Because we add stuff. But we don't remove. Now we remove it here for this node. Well, no, that's just removing from the top of the heap. What we also need is, in this one, we need to remove. So we remove this one, but we need to remove index -1, but not index -1, but no dot previous, more specifically. And as a result, because otherwise then it just gets all messed up. And there's references to the same node as a result. Okay. Wow, I'm just being really silly today. Okay, so yeah. Okay, so we already got the previous. So if previous dot value is not negative infinity, then we have to remove the the previous dot value plus this current node dot value. The previous dot index, and then just the previous node, right? Hopefully that fixes it. It's not in the list. Why not? Oh, because that's after we call removal, so things are a little bit awkward. Possibly. We definitely need to do it before we do the. No. This is just the heap removal, not the removal here. So this should be okay. Unless I'm so this removes this. This removes the So we remove this. So we remove this node. What does that mean? Well, removing this node removes this heap item and the previous heap item. Today I'm just struggling. I mean, it's all bookkeeping. There's nothing too tricky, but it's just about putting everything together in a consistent way, and I'm just struggling with it. I mean, you need something like this, but you also need it. But you're trying to remove it for index and index +1 or something. Where does this fail? This fail on this thing. Okay. So it's definitely just this. It's not like, as a result of other things being removed. Definitely it is wrong. All right, let's look at the state again real quick. I mean, I think it's something like this, but maybe I'm putting in the wrong place. Because you have this, right? And then this changes because, well, I mean, this doesn't really change. It's just that. Okay, so this is correct. But then this gets merged and then we never updated this, right? Because you have this, so this is the suffix. So it is trying to remove 0 for. Why does it give me a? Why does it give me a thing actually? 0 4. Maybe let's see. Let me take at least keep a look on 1 3. Okay, so you have this, and then now you know, when we move to 0 4, then now this should be a 3 3. Okay, so that's good. All right, so okay, so I think we made it a little bit better, right? And then you have this is 1, you move it, and then you have 1, which is 4, which is true. Oh, wait. This is confusing. Basically, the reason why this is failing is because it is trying to remove the thing that we just removed here, which doesn't make sense, right? So 1 is going to be 0. I think it's this one because the indexes gets crushed, but and because there's another one here, which is I think this one. Okay, so now so that's right. So that's we get up the heap, but why is the previous value, or is no.previous incorrect? I guess that's the biggest thing, right? Because this should just be, you know, print previous dot value, maybe. I mean, I knew that was gonna happen, but so the previous dot value is 0. What? Let's see. Let's just print previous, so then we get the entire tree, or not tree, linked list. So this is the previous. Huh? Okay, let's try again, right? So node and the previous. Is node and the previous the same node? Okay, so that's what I was thinking, but clearly it should not be. That means that I just screwed up linked list? So one of the reasons why I don't like think about it necessarily is because I don't usually screw up the linked list part of things, which is kind of very sad when I do. So this isn't even the first element. So where am I screwing up? Next is equal to previous dot next. Previous dot next is equal to node. No. Oh, what the? Wow. That is a bad typo. Okay. I mean, there might be other errors, but wait, let me actually double check before I just kind of put something in randomly. Previous dot node. I mean, this is definitely wrong, right? You don't set the nodes previous to whatever. No, I think this is more right. And maybe as a result, other things are kind of getting weird. I can't believe that. That's a really bad typo. Okay, so this looks right at least. But why are we getting a wrong answer? 102, no? Yeah, I mean, if this is the thing, then I don't know how 1 0 would be the previous. 1 is the value, 0 is the index. What would be this, right? Because 0 is the index. So maybe we updated it, but there's still a link somewhere. No, 2, 1. I mean, wait, where is this failing? Is it still here? Wow. But then how can previous dot value plus no dot value is equal to 1 if previous dot, if previous node is 2 and previous dot next is 1? Then how? Okay, maybe previous dot next is wrong. Do I not set it? Well, this is just no, that doesn't even make sense. Previous dot next, we see previous dot next. So how? Where is it? How does that what? All right, let's just point it out. Because I am just there's so many typos. I was 2 and -1, but no dot value is not -1. Oh, it is. Wow, I didn't notice the -1 to 1 switch. They have 2 different things. And clearly we got rid of the -1. So where's the node is equal to -1 come from? Did we remove this node previously? I guess. Okay, so we removed this node, but we still have a reference to it because we removed the wrong node somewhere off the list, right? Which is this one. This one's still alive, even though it shouldn't be. There's just so much bookkeeping, and I'm just, I don't know, not having a good day with it. Okay. But as you can see, it still stays, which is very wrong because we got rid of it a long time ago from the beginning. From here, we should have gotten rid of it. Okay, so this is the node, this is the previous. What does the 2 mean again? Oh, this is the, yeah, the 2 is the previous node plus the node dot value, so that's the 4. Why would we do 4? Huh? Isn't this the 1 thing? So it should be these 2. We do get rid of this because we got rid of this, so then we get rid of this, so then we should get rid of this, right? But this should also be gone. Which one is this? How? Oh, this is, well, so we are combining this and this, so we have to remove. How did I not remove this? How am I so dumb? Because the idea here is that I guess sometimes it baffles me because it's just so basic. Like we have A, B, C, D, and maybe I should have just enumerated, but we got rid of B and C, right? So this one is just getting rid of B and C. This one gets rid of A and B, and then we need to get rid of A and C and D. And I think the confusion is I thought I had it. Okay, fine, right? So then next is equal to node dot next. And I think that the thing is that I should have put it here on the remove function. I said that I would, and I think that's where the confusion is because now I try to combine the state so that's a little bit easier or shorter to write and a little bit complexity wise faster, but I should have just put it in here the same way that I put the heap manipulation here. The thing is that you're going to add and remove the same thing in the same combined operation, but it's less confusing, right? But that's basically the yeah. If next is not none, x dot remove node dot no. Oh yeah, that's right. I was gonna say and next dot next is not none. That's the confusing part because the other one we already removed here, so you have to remove 3 things, Larry. Okay. X. All right. Silly boy. Okay. I don't know. I missed. The real reason why I missed it is because I'm not doing it the usual way. I don't know why I'm trying to get away with shortcuts, and that's where the confusion is. Because usually, like I said, I would just pay the extra complexity and then just put in remove, right? So what I'm gonna solve it anyway because I'm annoyed at myself for not doing it. So we should not have these two things here, even though maybe it's fine now that it's done, but the remove should have handled it, right? And what this does is that now we remove node, right? Yeah, I mean, and that means that we don't do this remove either. I think that's what I'm trying to double check on. So then here, right? So if next is not none, then we remove node.value and node.next, right? Node.value plus node.next.value. And then we have node.index as keep track, and then node, right? And if previous dot value is not infinity, even this is kind of ugly to be honest, then we remove previous dot value, put node dot value, node dot previous dot index, previous, right? And then now, so then we do the removal. And then as we solve this removal, we have this thing which combined the two new neighbors. So then now you add back in if previous is not none and next is not none. The previous would not, in this case, is actually the negative infinity thing. Then h.add previous value plus next dot value, previous dot index, previous, right? So we add it back in, and we also add in. No, that's it because we remove. We should only have one new assertion, right? New addition, I mean. Okay. Did I misspell something? Wait, where is it saying that? Oh, I think it's because I commented out. Where did I put it? Oh, I just deleted it, I guess. Where? Huh. So that, oh, no. So we should have removed it here and then added it here. The reason why this is saying that is that that means that previous of index is not unique, and also this is not unique for some reason. What? And I'm just going nuts. And as a result, it's trying to sort by this element, and it's not, you know, doing it right. Where am I going wrong? Did I do the order of operations right? Previous. No, I mean everything should be fine on the previous of index. I don't get it. Is that, well, maybe this was inserting stuff as we add back in. Do I not remove enough? Okay, let me think. Okay, so here we have A, B, C. So then we're just saying that we remove B. Then now we remove B plus C, and we remove A plus B. And then after removing B, we have, well, A plus C, right? This should be right. It may be that I need to order my add as well. Right? So then now add, right? So then here, let's say we have ABC, right? Oh, sorry, just AC. And then now we're trying to go ABC. So then now we're trying to remove this, and we didn't. So that's why there's a confusion. Because I wasn't consistent. Or yeah. I mean, I am not smart. So yeah. So then you have this thing. Well, you have if previous dot value is not negative infinity, and so you have to basically do the invert of it. Is not none. Then now we want to remove previous dot value plus next dot value, previous dot index, previous, right? And hopefully that should be good. All right, let's give a YOLO submit. And the reason why, like, this is more preferable than the first time I wrote it, even though, well, the short story is because it requires more juggling in my head, right? Because as you saw, like, it's just easy to miss an item. And here, even though it still looks confusing and the code is still messy, to be frank, you're able to kind of isolate it into a smaller thing to test, right? So if you're thinking about it in terms of test-driven development, right, then here you can just test this in a way, case-by-case way. We test this in a case-by-case way, and then it doesn't matter how you use them in any order. And then now we just have to, after that, we just insert this in the right order and we're fine, right? But trusting that, this is, because then now you could say it in English. We want to move this node, the next node, and then add a node after the previous. And it'll handle all the heap stuff for us. And that's really what we want. The reason why I didn't do it, and you could kind of maybe see it if you saw it, is that this is just much slower because we're doing additional adds and removes that, that you don't have to per se. But as you can see, it just, took so much longer that, I don't know, right? I mean, it's always tough on Leetcode as well because like 7 seconds may be a little bit already on the slower side, right? Meaning that, like if they add, I don't know, what is it, like 50% more test cases, maybe it times out. Who knows, right? And you can't really predict it. So it's a little bit tricky, but this is like the cleaner way of doing it, even if it's, there's an added cost, right? I'm curious how I did it in April because I don't know. I did do it with. I guess I mostly did it the same way, though. I did it in this crazy man's one loop, one craziness. What is total again? Total number of out of orderness. I guess I did the same thing here, which is basically what we did. And actually, surprisingly, we didn't really have much issues with that one. I think I missed one of these, but yeah. I think one thing that I should have done maybe is also use a sentinel on both. This one I did negative infinity side, but I don't know. I guess this is actually more or less the same code now that I think about or look at it. But maybe I just had a cleaner head that time, and today not so much. So I needed extra help with programming. But yeah, this is a very long way. Wow, it ended up taking an hour. I don't know. I don't think it's that hard. I guess the idea wise, I don't think it was that hard, but implementation wise, clearly I struggled. So there you have it. That's all I have for this one. Let me know what you think. Thanks for watching. And if you're watching to the end, let me know. I've been watching Fallout, the series on whatever. Let me know if you're watching it. Let me know if you like it. Right now I'm watching it and I enjoy it a lot. So let me know. Thanks for watching. Stay good. Stay healthy to your mental health. I'll see y'all later and take care. Bye-bye. Oh, I didn't go with complexity. Did I? Okay, let's go with complexity really quickly. Again, this loop, every time, this is the same thing I said yesterday, which is that every time this loops, you're going to have one fewer element, so it's going to be at most of n loops, right? And each of these we do 2 removals and an add. Let's take a look at those, right? Removal, we do, I don't know, 3 log n operations, right? And a lot of complicated whatever, but we do 3 operations on heap. On add, we do also 3 operations on heap. So this is going to be, what, 9 log n operations, which is, yeah. So, but still log n. So it's going to be n log n, expensive n log n, but that's all I have for this one. Let me know what you think. I need to take a break. Thanks for watching. Stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye-bye.